hearty welcome to all the attendees who are present here today for the National Engineers Day celebrations. The theme for today, as you would have seen in our brochures, is basically engineering innovations in medicine, pioneering advances at the intersection of technology and healthcare. For today, the program what we have laid out for the esteemed audience is as flashed before you. Initially, we plan to have a short welcome address from Professor Indranil Manna, President INAE. I will request him once our chief guest joins. Then we expect opening remarks and a lecture by Dr. S.K. Sarin, who is the President of National Academy of Medical Sciences, besides being the Director of world-famous ILBS. Then we have talk from our distinguished speakers, two talks. First talk is by Professor Suman Chakraborty. He is an esteemed professor at IIT Kharagpur, our fellow. And the second talk is from Professor Rohit Srivastava, an esteemed faculty at IIT Bombay. Both the topics you will see are converging towards how to democratize or make healthcare technologies affordable. So that is fundamentally the crux of today's talks. Esteemed chief guest of ours, that is Dr. S.K. Sarin. We welcome you heartily for this INAE Engineers Day function. It is on the occasion of National Engineers Day. And as you can see on the view file, that is the program for today. Then I will now, without any further ado, request Professor Indranil Manna, President INAE, to kindly make the opening remarks for today's function, and then we can get going. Over to you, sir.
Yeah. Very good morning to Dr. Sarin, our esteemed chief guest of today's function, the two very eminent speakers, Professor Suman Chakraborty and Professor Rohit Srivastava, and all the fellows and associates of Indian National Academy of Engineering. It's a very memorable day, very important day for the entire engineering fraternity, and I would say beyond engineering and technology fraternity, because today there is no boundary, there is no sharp interface. We are very fortunate today to have Dr. Sarin with us, and I must say that it was he who actually was very keen and wanted to explore possibilities of collaboration between National Academy of Medical Sciences. He is currently the president of NAMS and INAE. We have had some discussions and we intend to take it forward. That also proves that, in medical sciences and technology, there is enormous amount of interface with engineering, devices, implements, and so on. But at the same time, we keep talking. We haven't been able to conduct a joint function so far. But then I thought that why not use the Engineers Day as a suitable platform to showcase some of the exploits made by our fellows of the academy, who are basically of engineering background, but they are doing very extraordinary level of work, very innovative work at the interface between medical science and technology and engineering, application of engineering knowledge. See, friends, all of us would agree that we live in an era of knowledge, and nobody wins anything by brute power or force. Today, the world progresses by virtue of the advancements we make in the knowledge domain in any given area. Engineering is no exception. Engineering actually emerges as even more important than ever before, because India has a very rightful ambition, by the words of our Honorable Prime Minister, to emerge as self-reliant, Atmanirbhar, and also a developed nation, Viksit Bharat, by 2047. In order to pursue this agenda, despite being the fifth largest economy in the world, we know very well that most of the developmental agenda before the nation are to a large extent engineering oriented, be it energy, water, environment, climate, habitat, transportation, security, both digital security as well as physical security, in anything that we think of. But what is even more important is that today the well-being of the humankind is very much dependent on the advancement of basic sciences and applied through engineering and medical intervention. So with this in mind, we thought of using today's very important occasion Sir M. Vishweshwaraya's birthday that the entire nation celebrates as the Engineers' Day, we all are aware that he has been all along the biggest icon in front of the engineering community, not because he was responsible for design and construction of the Krishna Sagar Dam or one or two other irrigation projects and so on. Even during the British India period, he was able to implement very major engineering plans and designs. And rightfully, we look at him as a source of inspiration, an icon before the entire engineering and technology fraternity. So this is the right occasion when we would hear from two of our eminent fellows and experts, and more importantly, from someone who is not only one of the most eminent medical practitioner of the country, but also is a very renowned scientist and has made enormous contribution in his subject domain. So with this, I won't take any further time. So Colonel Rai, I would like you to formally introduce Dr. S.K. Sarin, our chief guest.
Indeed fortunate to welcome Dr. Shiv Kumar Sarin. He is the director of the world-renowned ILBS and president of National Academy of Medical Sciences. And of course, his designations are as flashed before you. He is the chief guest for today. Dr. Sarin is an internationally acclaimed hepatologist and gastroenterologist. He is the director of the Institute of Liver and Biliary Sciences at New Delhi. And as you can see, he's had a distinguished career of more than 30 years in various fields related to liver disease, innovations, medical education reform, etc. He's made significant contributions in understanding of liver diseases, and his treatments are widely accepted worldwide. He's a driving force behind the ILBS and helped develop the institute into Asia's leading center for liver and biliary sciences, cutting-edge work and educational reforms and programs. His work on prevention and treatment of hepatitis B and other diseases have been instrumental in improving public health. His academic achievements include numerous publications in world-renowned journals in the field of essentially liver disease and other fields, and also he has been author to many books and chapters in various technical publications. He's a key figure in public health initiatives, spearheading especially hepatitis B related programs in India and worldwide, and also various campaigns such as the famous Yellow Ribbon campaign, which has significantly raised public consciousness. He has also been a mentor to many PhD and other students in his field. His leadership in the field of medical sciences extends beyond India, and also he has been honored through various awards across this stream, including the Padma Bhushan, the Shanti Swarup Bhatnagar Award, and prestigious international recognitions such as Third World Academy of the World Medical Sciences Prize. So with that, a brief introduction, allow me to welcome Dr. S.K. Sarin on behalf of Indian National Academy of Engineering and deliver his talk. Over to you, sir.
Profuse thanks to Professor Indranil for inviting me and making a doctor speak on this very important day. And I thank you and the whole engineering fraternity. A happy National Engineers Day. I have greetings from the Institute for Liver and Biliary Sciences. And I'm going to talk of something which you may already know, but this is a doctor's heartfelt gratitude to engineers. National Academy, inaugurated in 1961 and the first convocation in 63. So my disclosures are, I have no conflict of interest and I have no particular talent. I am merely inquisitive. And observation is what we do, and our patients teach us every day to be humble and to learn more so that we can serve better. So you know fully well how the medical science evolved twined with engineering base. When the famous Sushruta could not do with his hands, the story goes, he went to a iron smith, the Luhar, to get some instruments made, and that's what the surgery started, and now you have at present so many things. And of course, the future of micro robotics and diagnostic and drugs is the future. But let me come to the bottom of it. Normally, we have physicians who have problems they can't solve, they don't know what's happening. And there are engineers and IT people who design things thinking they can solve the problems, and there is hardly any mix of the two. And the engineers develop products, and the physicians develop some solutions which never meet. And finally, the market is always depleted. Can we not have a system today starting where we all understand our limitations and also understand the needs, what we can do for the future? And I feel we need hybrids, we need crossbreeding. There is hybrid music, there are hybrid computers, but there are very few hybrid scientists. And we need to have a ground where they can breed. Where would they breed? You will make your own type of, let's say, neurologist or hepatologist, liver guys, or you will make your own IT engineers. But where is the ground for mating? We need your inputs, dear engineers, and I have listed out a few. I'm not going to make it a long talk, and I'll tell you some of the things which I feel if you pay attention, we can change the world. First is a polygenic risk assessment, and of course, digital twin for health and the new generation. So I'm actually witness to this human genome, which was published in 2000 March, both in Science and Nature. And 2 months later, US started the courses of computational biology. A biologist can become a computer scientist, and a computer scientist can become a biologist. And the courses started 2 months after, from May 2000. Where are we? Have we created a hybrid? I'm trying to show you what you and we can put together, integrating genomic innovations, Internet of Medicine, point of care devices, and public health strategies for non communicable disease reduction. Fatty liver is core to diabetes. So, diabetes is a liver disease. Blood pressure, your high cholesterol, your cardiac events, your cancers all come from fat in the liver. And more than 30 crores Indians have fatty liver. Maybe all those engineers listening, less numbers because they work very hard, maybe 1 in 4. Of those who have fatty liver, 15% every year get heart disease. So heart disease means there is fatty liver. Kidney disease is there, liver, brain, Alzheimer's, dementia. It's additional inflammation due to fat. Now there is an omics innovations, huge amount of data. Can we use all this for early diagnosis and risk stratification and reduction in NCDs? Let me tell you what I understand from a precision medicine. You have big data of 100 million people, electronic health records, machine learning. You have their biosamples, blood, urine, stool, tissues. You apply all omics and transcriptomics or metabolomics, glycomics, lipidomics, all RNA, DNA technology. And then you say, all right, we should have this kind of a drug. This drug or a old drug which can be repurposed, either it fails or passes. But then you take this path and you develop a precision medicine. Precision means 4 out of 10 you are correct, 6 you may be wrong. And then you go finally to a personalized medicine where 1 for 1 there is a success. Let's see how we can do using engineers. So there are four main genes which are there. One is PNPLA, another is TM6SF2, HSD, which is a good gene, and GCK, the glucose kinase receptors. These are all bad genes. So you develop a risk score. If somebody has a PNPLA, you have 3 times more risk of fatty liver and heart disease. This has 2 times, this has 1 time. And if you have HSD mutation, you are protected. Now you have a huge population, and why I'm telling you is because where the new cusp starts. So you have a polygenic risk score for India. Let's say you do 1% population of India, maybe 130 million or so. So a few will be on the low risk, a few will be on the very high risk, require immediate, majority will be in the median. Our job is to find out which genes, which population is at high risk. If you identify them, you will be able to say, oh, he will not die of diabetes or heart disease or cancers. India has not started such studies, and where we need to have a risk score using big data, engineering tools, point of care devices. What do we do currently? And this is so interesting. You have fatty liver to cirrhosis. I'm not teaching you on hepatology, and there are some blood markers. This machine is called FibroScan transient elastography. This machine is the most popular, costs about 1 crore. Was developed for finding out the quality of cheese. It is a low frequency ultrasound. So the sound waves go in. If they hit a hard liver, they come back early, maybe 30 milliseconds. If the liver is soft, in 60 milliseconds. But this was evolved from assessing the quality of cheese in France. Now we use it for human beings. There is no Indian version available. We are using proton density fraction, PDF analysis using MR elastography, costs several crores. The cost goes on. Can we develop all the assessment devices in a very cheap manner? All right. So there is a concept which I propose to you. You can have demography, clinical, lab, biogenomics, all histology. You have models, then you develop non-invasive model, and you develop something which is affordable, available, acceptable, and accurate. The engineers can do it. They just need to probably know what is the biggest problem. And I think the next generation will be driven by non-communicable diseases, fatty liver at the core. A small break, scientific bio break. 2004 or 5, I was at the University of Hyderabad to give some talk. And my good fortune, Professor CNR was in the audience. So I asked the whole group of people, well, how many of you wanted to become a doctor? Please raise hands. Everyone raised hands, including Professor CNR. Then I asked him, sir, why didn't you become a medical doctor? And see the candid reply. He smiled and said, I got into medical college, but it is 5 long years. I didn't want to waste my time. I agree with him. 5 years is a long time for a creative mind. Our medical studies should be short, and also that you can be as creative as ever, and the mind is there. So here comes the new cusp. The new cusp is we had the Human Genome Project, and now the Human Genome Project 2, HGP2 is starting. This is September, 3 days ago. What the project says is 1% gift to humanity. Sequence the genomes of more than 1% of the world population. Genetic representation of 80 million from 100 countries. What are you going to do with it? Embed genomic multi-omic findings into standard clinical practice and precision public health. Where is India? We need to find out. I'll briefly touch what you are very familiar is the digital twins for health. What I'm showing you is in March 24, the Chinese premier announced digital twin technology is one of the 6 new productive forces and the government to give actually top priority for digital twin technology. In India, I searched, we have only Chirac D2, DT, Indore IIT. But where are we in digital twin for health? Today, Professor Indranil has asked me to address the whole group of engineers, and I would like you to think, don't you want that what you are likely to suffer or what drugs are likely to make you healthy, we should have digital twins for everyone. Let's decide the timelines and move forward. There are so many companies I could see which are in digital twin for health, for lung, for heart, for all these. And in India, as I showed you, probably one. I know many are working, but we need to work much, much faster with a speed unknown to others. My second area where we need inputs, I'm not going to cover all, I'll just cover two, is organ regeneration and banking. You don't realize the value of health till you fall sick. And one of them is a failing kidney, a failing liver, a failing heart. So now this guy, all of you know Yamanaka factors. Yamanaka got a Nobel Prize in medicine for finding out induced pluripotent stem cells, IPS, which is the way to make new cells. But who is this Yamanaka? He's an orthopedic surgeon. He is not an engineer, but he turned into basic science, engineering, and he became one of the best known cell biologists and innovator. Can't engineers do the same, join medicine, and become the best innovators in medicine? We need liver transplant. The liver is my area, so my limited knowledge and apologies. For about 200,000 people, 2 lakh, and we do about 4,000 in the country. So is there an alternative to liver transplant? We started with liver cell transplant or the ESCs to be transplanted, induced pluripotent cells, developing organoids, developing bioengineered organs, and I'll show you one slide on that. And now the xenotransplant, whether it is pig or others. Well, we are far from generating livers. Can we not have? When I was studying, we were thinking, oh, by 2000 we will have a bioartificial liver. 25 years have passed, we haven't reached there. Today, you get a liver from a cadaver, you have to put it on a cold storage and use it in maybe 10 hours or so. Whether it is day or night, doctor has to work. But can we do a liver preservation concept change to liver banking? So now machines are there for hypothermic, making it low temperature, normothermic, where you can keep the liver for a few days, super cool, where you can keep it for weeks, and maybe vitrification, where you can do banking and it allows you time. We are in 2024 here with several machines available, very expensive, but I would urge the engineering group to find ways where you can keep the organ as a bank. Like you have blood bank, can we not have an organ bank? Let's think. Thinking is what you require. Myself, with a group from Dr. Ashok from IIT Kanpur, we were able to develop something, many more, but this is just one I could pick up. This is a liver. You decellularize the liver, remove all the cells, put new cells, allow them to grow, and try to make a new liver. It hasn't succeeded. One of those things which can be done. What we have another concept is a normal liver. When somebody drinks, has fat, or has hepatitis viruses, he gets cirrhosis. Now, once there is cirrhosis, then because of the inflammatory signals, the bone marrow becomes damaged. And once the bone marrow becomes damaged, you can't repair the organ. So our concept now is to improve the bone marrow by giving cells. We need engineers for finding out better ways of introducing materials and also delivering improving livers by not liver transplant but doing healthy bone marrow transplanted in a liver patient. ILBS is a unique place. I'll just one or two lines on this, where we have clinical people, we have academics and research and training and skill, and the PhD students, basic scientists, and the clinicians grow together. However, we don't have any engineers or AI people or bioinformatics. We are lacking, we need them, we are waiting for them. ILBS has an advantage. It has the National Liver Disease Biobank. We have more than 340,000 patients. We see close to 150,000 new patients, but these are in the biobank. We do imaging, we do their admissions through emergencies, and we have a phenotyped patient. We invite you, all the engineers, to use this huge bioresource for developing state-of-art work. There are labs which are waiting for the engineers, the liver innovations and virtual artificial reality labs. So we want you, like us, to be unconventional. ILBS invites you for a large impact, small, indigenous, short-term, but new technologies and new, highly technical long-term impacts. Why I'm picking you to liver? Look at this. This is 2000 years before Christ. This is gallbladder. This is the structure. And these are all the inscriptions in maybe Latin. So liver was worshipped in the temples, and all the movements of the kings and the armies were based on the directions and writings on the liver. What you have today is the horoscope is coming from the liver, which is heriospicy or hepatoscopy. So love your liver, work for liver. I'm not going to tell you more about engineers, about gut microbiota in food. What we need is what you eat. Can you find out the bacterial products in the bowel? Can you find out the type of bacteria? And there is work going on. You put in a capsule which sends you messages, but it doesn't tell you which type of bacteria and how much. We need tools to look into the bowel without entering there. We need tools where you have cancer therapy and how your immune cells work. We of course need nanotechnology for drug delivery, microbots, especially miniature robots which can do cellular surgery, and of course drug deliveries. We need wearable devices, implantable technologies very, very rapidly, and innovations in medical imaging. India needs to change. And these are my messages for the Academy of Engineers today. Please, if you like it, take it ahead. Teach biotechnology from class 6. Don't just teach biology. Start changing to biotechnology. Teach setting up startups from 9th standard onwards. We don't know, even I don't know today, how to start a startup. Tell them to do self-earning using startups by class 12. You study, but you have a small startup. You prepare something from paper, something from wood, something from steel, and don't waste it. Of course, I strongly recommend a 6 months posting project in medical college for the BE, Bachelor of Engineering. You all do minors, maybe minors in physics, minor in something. Why don't you do a minor in medicine? And my most important message to you is open engineering units in medical colleges. Today, we are trying that a medical college comes into a engineering school or engineering college, patients won't go there. The better way is what the Germans do or what the French do. All the INSERM units are the engineering or the basic science units are in hospitals. So reverse is a better way, open engineering units in medical colleges. National Academy of Medical Sciences, which I represent, is an umbrella. It invites scientists of eminence from basic science, medicine, biomedical, engineering. That's where I had the privilege of meeting the president, Dr. Indranil. He was kind enough to come to us. And I would once again urge engineers to also become a member of the National Academy. If possible, vice versa. If you allow us, some of the doctors might join and become members of the Engineering Academy. But we need hybrids. Why? Excellence is like a fluid. You be an engineer or you be a maybe doctor. Yes, if you have the talent and if you have the hunger and desire, you will become what the country needs. So I would like to end a happy National Engineers Day by saying a share if you allow. यह मत सोच कि जिंदगी में कितने पल हैं, यह मत सोच कि जिंदगी में कितने पल हैं, यह सोच कि हर पल में कितनी जिंदगी है. Start today the journey for hybrid engineers and clinician scientists.
Well, thank you so much, Dr. Sarin. I don't know how to express my gratitude and I didn't know. I mean, we all know that you are a great doctor and a great scientist. We didn't know that you also are a shire. So excellent. And Dr. Sarin, I certainly would like to take it forward. You gave us a number of leads, starting from big data analytics to digital twin initiative of China, what we can do. Most important thing is that to develop Indian version of very many important life-saving medical instruments and devices. I think this is one agenda which the country must pursue very, very rigorously. So we'll find a way to create a small group of people to interact. Maybe you can propose some 3, 4, 5 of your colleagues and 5 from Indian National Academy of Engineering, and we could sit together and then come out with some recommendations that will definitely be to the benefit of the country. So thank you once again.
So moving ahead and setting the tone for the talks, we have with us Professor Suman Chakraborty, and his topic, of course, is community transformation via democratized diagnostic techniques for the underserved. Before we invite him for his talk, a brief about Professor Chakraborty. I hope you are able to see my screen, and you can see that his areas of work include microfluidics, nanofluidics, micro-nanoscale transport, with particular focus on biomedical applications, including novel diagnostic technologies for affordable healthcare. Now, he's an eminent scientist and a technologist, member of all the academies in country and abroad, awarded numerously, as you can see. But for the want of time, I take this liberty and without wasting any further time to invite him for a very anticipated and interesting talk. May I invite you, Professor Chakraborty, for your talk, please?
I must express my sincere thanks to Professor Indranil Manna for giving this platform, very prestigious platform of the National Engineers Day. I am deeply humbled to actually speak in front of a legend, Dr. Sarin, the legendary figure in Indian liver disease community. We all respect him tremendously. And sir, if I make any mistake in any medical terminology, please forgive. I am also deeply honored to share the platform with my young colleague Rohit, who is an outstanding scientist, and I believe that we will be able to come up with some recommendation at the end, and we have seen Dr. Sarin giving excellent recommendations of how we engineers can take forward the medical research and technology development work. So by taking the lead from Dr. Sarin's talk, as engineers, what we can do in the healthcare arena is something which needs much more focus than what it is currently drawing. There is a general belief that engineers can develop technologies and the technologies will directly get into the use by the medical community. Having said that, it is not as straightforward because human health is a very complex phenomenon, and working with human health is not like developing a machine or designing a machine and making the machine effective in a condition which is designed for certain purposes, because there is a huge variability and there are certain issues which make it very challenging. Now, one of the major issues where I want to focus on is the diagnostic technology, which is primarily the area in which most of us who are engineers and who work in the healthcare domain would invariably have some overlap. But at the same time, through my experience in working with diagnostic technologies, what I have realized is that it is not just the technology, but what I would summarily say as technology plus, something more beyond the technology, which would make sure that whatever interventions that we are planning for is actually effective for the benefit of the common people. Now, a lot of these technologies which I am going to summarize, these are for primary healthcare. And when we say primary healthcare, the emphasis is not really to go for something which is a very so-called high-end aspect of the technology per se, but a technology which is simple, effective, and it can be disseminated to the last mile. Now, it is easier said than done, because the challenge is that when we go to the grassroots level and try to implement technologies, there are certain inevitable issues. Fortunately, with a lot of effort and initiative from the government and also the private sector and not-for-profit foundations, the digital health model is now very well spread across the country. And we all know that the modern era is an era of the digital technology and data sciences and communication in particular. Everywhere the internet connectivity is much better and improved as compared to what it was maybe 10 years back. So the digital health clinics, which maybe 10 years back were finding their challenges to operate, now with all the learnings that we have got from the COVID era, the online, or what I would say as the digital mode of communication, is so good that many of these digital clinics are functional quite effectively. I have given an example here where, with the help of our on-field partner, which is a not-for-profit foundation for innovations in health, led by Dr. Shatadal Saha, we have developed an outreach at different places, even up to the remote Sundarbans, where we have the hub and spoke model in terms of maybe a central location followed by decentralized approach through frontline health workers, who are typically the rural girls, who are trained and empowered with certain technologies so that they interface with the patients. The patients share their issues with them and they enter that in a digital platform, be it a tab, be it a mobile smartphone, and then that same is communicated to a remote doctor who is sitting somewhere else, but the remote doctor can quite readily communicate with the patient. Only barrier maybe the language, but typically if the doctor can speak and communicate in the language of the patient, then this is never a problem. Now, where the main challenge of this system comes is that the doctor will recommend, of course, some basic medication and invariably some diagnostic tests. And these diagnostic tests are neither easy to do at the site of the patient. If they are done, it may be low cost, but it may compromise with the medical standards so that the result may not be acceptable, or the patient or the sample has to be transported to a remote center where there are other inevitable compromises like the patient's inconvenience, loss of daily wage, the delay in the results of the diagnostic solutions. So keeping all these into purview, the technology development in diagnostics that we all work on, they are not simply designed to be high-end technologies. They should be directed for certain innovations which will satisfy these boundary conditions. I have summarized those in a tabular form because as engineering designers, we always have to understand the constraints. We are talking about technologies which are no more going to be used in a high quality lab where you have highly controlled environment, including continuous power supply, high quality storage and transportation system, highly established supply chain of delicate materials, highly trained human resources, and usually when we are referring to the technologies in the high-end labs, we are not so much bothered about the cost factors because there the technology and its robustness becomes the major focus. And that is how the scientific innovations in any sphere have been going on over the years. The glamour of science has always been reported as outcome which is cutting edge and which can disrupt the scientific community. Now, here we are talking about solutions which are definitely to be cutting edge, which would disrupt the community at large, but at the same time, it is not having the privilege of the lab conditions, which normally would be there for any technology to function. So I would give a few examples with our journey that we went through over the last several years. So we started with our focus on body fluid based test with the finger prick blood as an example, where using paper microfluidics, we have one drop of blood and we have a paper strip where the blood is just sucked in, and there is a micro channel on the paper which will make sure that the blood will move in a certain direction by capillary action to a site where there are reagents, and there is actually a very small filter in the paper strip which will separate the plasma from the whole blood, so that we can have only the plasma entering into the reaction spot, and then the reaction colorimetric change is recorded in a smartphone. The strip is inserted into the small box which is like a credit card reader where the credit card is inserted, and then you can have a mobile app which is taking over the image grabbing, image analysis, and from that we can get a result of the diagnostic test. So this is a summary of many of the tests that we have developed in this way, but at the same time there are interests on different variants of similar technology with the central mission that these technologies should be able to work in a resource constrained environment. Dr. Sarin was talking rightly about the fatty liver disease as one of the major challenges, and these are all non-communicable disease burdens complexly connected with various other diseases including the cardiovascular ailments. Now in the point of care arena, we do not have much of a simple low-end lipid profile test, which we'll talk about the different variants of cholesterol, LDL, HDL, and triglyceride. So we try to adapt the technology of the lab on a CD, which is a mini centrifuge. You can see at the bottom the video running. So you have a small motor which is spinning a disc. Inside the disc there are micro channels which are made by simple mechanical manufacturing and where a lot of engineering comes in. When it is rotated, the blood will simply move by centrifugal action, and the plasma which is separated is collected at different chambers in the same CD, and there are reagents for LDL, HDL, and triglyceride. It will react with those reagents. One of the major engineering design factors is how you program the rotation of this disc to make sure that you have optimal reaction conditions. And after the reaction, the color of the spots will change, simple colorimetric principle. But what we have done is we have not used any smartphone based analysis for this, but because there are multiple spots here, what we have done is we have adapted a office scanner and made a central hole in the office scanner which is of the same size of the CD, and scanned this entire thing using a scanning software and used image processing with a bit of AI to make it more precise and quantitative to get the screening test results for LDL, HDL, and triglyceride all coming up within 10 minutes of the sample dispensing. We have also worked significantly in the infectious disease detection space, and this particular technology which we tried to develop during the COVID era, when there was significant crisis in getting the RT-PCR test done because of the challenges in accessing the RT-PCR centers where huge numbers of samples were to be tested on a daily basis, typically during the peak waves of the COVID. So we developed a portable simple machine where instead of the PCR, the thermal cycle based test, we made it isothermal, piecewise isothermal nucleic acid testing machine, which is called a SPINAT machine, and we applied it for COVID diagnostics. The particular application was known as COVID app, which was introduced from IIT Kharagpur at that time. And once we got it US patented, we tried to move on, and based on the current Indian scenario, we tried to adapt it for the TB diagnostics with the kind support of ICMR. And we have also tried several innovations to make this somewhat simple. That is a bit of adaptation of the sample collection itself, so that instead of the swab, we can have a saline gargle based test. So this is something on which we have been working on for some time, and I believe that with all these simplifications, the challenge which we have all faced is the compromise in the accuracy of the test. So how can we make engineering innovations to overcome these challenges? So if we look into all these innovations, the major challenges that we tend to face, and I think this is a challenge which is a combined engineering and medical aspect, is the optimization between engineering elegance and simplicity and medical grade acceptability. So if we make it too simple, too frugal, it may not be acceptable from the clinical standards. This is another example where we have tried to adapt the paper based technology for evaluating antibiotic resistance in urinary tract infection. So it is simply the cultured E. coli which is being brought in contact with the antibiotic medicine, and then if the antibiotic medicine is able to kill the bacteria, then we have another layer. It's a multi-layer folded paper kit. There is a blue colored chemical known as chromogen. So if the bacteria is being killed within a couple of hours, this blue colored chemical will tend to get into pink color. So the fractional change from blue to pink will be an indicator of the efficacy of the antibiotic. And it is very important as a life-saving measure for the doctor to have an a priori understanding in a personalized manner about the potential efficacy of an antibiotic medicine before it is administered. Getting into the imaging arena, we have also been working closely on the cancer screening program, and this is one of the major programs in which we have been the screening of oral pre-cancer and cancer, which is one of the major public health challenges typically at different locations where the tobacco as a consumption is a challenge. And of course there are other reasons for oral cancer which may start with HPV or other forms of infection. So if we combine all these challenges, then this is an opportunity where instead of going for a simple optical based screening, we have a system which is a torch like device which will take the thermal image of the lesion inside the mouth, completely non-invasive, and convert that to a blood perfusion image. And from a classification algorithm used with the help of machine learning, we can classify or categorize in this way pre-cancer and cancer patients and segregate them from other types of patients. We did first level of clinical work with the Guru Nanak Institute of Dental Sciences and Research, and now further developments on this technology is going on to make it more inclusive. We have also tried to endeavor on using the rich physics of fluid flow to adapt them into reagent-free diagnostics. So this is one classical example where we have a moist filter paper, where we have glycerol soaked in it, and when we drop one drop of blood, the pattern in which the blood spreads, which is known as viscous fingering, as a low viscosity fluid, it displaces a high viscosity fluid, in this case it is glycerol, it tries to develop a pattern. And from analyzing the pattern, it is possible to tell what is the volume fraction of the red blood cells in the sample. And in that way, one can use it as a readily approachable or readily accessible tool without any reagent for quite an accurate screening of anemia patients. But having said all these, one of the major challenges that we felt that many of these technologies have is that they need devices. Now, as engineers, we want to, or we love to work with devices, but we have to imagine that devices are not quite convenient if you want to make the test highly portable. If there is a diabetes patient who has to travel quite extensively, it is not so convenient that the patient carries a glucometer alongside with him or her and makes the test maybe whenever the person is there in a community center, maybe in a meeting, in airport, railway station, etc. So we try to migrate from device based to device free technologies, and then I started mentoring a startup known as Smart QR Diagnostics with the kind support of the DSIR, Government of India, through their CRTDH program. And then they blossomed from there and quite quickly adopted our technology, licensed that, and converted into a form of technology which we applied to different forms of diagnostic kits which just require a paper strip and a smartphone, no other device. So this is an example which is known as PrePap QR, where there is a paper strip and a mobile app. So this is a vaginal pH test that woman at complete privacy can perform. So it's a self collection of the vaginal swab, then putting it on the paper strip, and it is completely coded, and you take the picture of the paper strip, and you can see how the entire test works. So there is a strip, and once a picture is taken, the strip will be digitally analyzed, and the result of the vaginal pH and other forms of data will come out of that. We have always tried to use these technologies for resource poor settings. So in Sundarbans, we have tried to adapt these technologies under certain conditions where you will see that marginalized women who are not quite open to discuss their reproductive health issues to others, they try to get familiarized with this technology with the help of frontline health workers, and now they are using these technologies, and the results which are obtained from there readily, these results are made available through the mobile app to specialized doctors. So in that way, what we have tried to do is to not just develop technologies, but try to make an ecosystem around the technology. So the technology is developed in the lab. It is designed in a way so that not just in the lab, it will work in extreme harsh conditions where you do not have any reagent supply, because all these kits or all these strips have lyophilized reagents. They do not require any liquid reagent per se to be dispensed. You do not require a device except for a smartphone, which is available at most of the places. And there is a simple demonstration video or app which will guide the person to do either the self test, or the frontline health worker, who is a minimally trained girl, will be empowered to educate the local women and youth and even the school children to adapt these technologies and take their benefit. So the whole emphasis has not been just to develop a technology, which is definitely important, but how to connect it with a holistic rural transformation. That means train and empower the frontline health workers, maybe encourage them to form enterprises, and encourage the startups to become entrepreneurs working on these kinds of technologies which are not so common, and then convert it into an ecosystem model where the local schools and community centers, they take part in a holistic transformation where we have certain pointers which we are trying to address. A Make in India scalable and sustainable solution for a global challenge, which will give more access to primary care at resource limited settings. Deployment oriented R&D ecosystem for the last mile primary care, including public health research and intervention to improve societal health indices. Facilitate large scale population cohort studies for understanding disease evolution, epidemiology, etc. through genetic, metabolomic and drug development research, which is one of the major points that Dr. Sarin was aptly emphasizing on. The last 2 points are bit more bit deviated from the so-called technology, that is livelihood generation, women empowerment and rural entrepreneurship. And it is all possible through such simple but highly needed technologies, and these are certain interventions which will generate new employment and job opportunities, and it also creates a new identity for any institution or the government as the friends of the community. So to summarize, what I can say is that it is not just one technology as a solution, but an intervention in an ecosystem approach. This is an example. This is a village known as Barra, which is located in district Birbhum in West Bengal, where in the pre-COVID era we started our journey by making diagnostic test camps, where some of our technologies which were at that point field validated, many of those are commercialized by now, but which were field validated at that point of time. So we tried to emphasize on developing the skill of the local community, including women, and I tried to mix our students and other staff who are working selflessly for these kinds of projects to develop a teamwork which will not just work on technologies in the lab, but which will disseminate at the last mile. So I would like to thank many of our collaborators, mentors, colleagues. There is a long list of very highly expert human resources and professors, medical doctors, industry partners, but more importantly, all these work because we have financial support. So I would like to thank in particular two important financial supports. One is the CRTDH, Common Research and Technology Development Hub on Affordable Healthcare, which has been generously sponsored by DSIR, and the ICMR Center of Excellence in Healthcare, which has been supported by the ICMR DHR, and also various forms of support from the DST, the Ministry of Electronics and Information Technology, the Department of Biotechnology, IIT Kharagpur and IIT Kharagpur's alumni chapter, and various other private organizations, and of course our industry partner Smart QR Technologies for bringing a couple of these technologies from the lab to the market, which is now currently available in a commercial form. And I'm really very humbled to see that they have already received millions of orders of these kits, which I dream that with the help of all the stakeholders at some point of time will be in a position to create a very disruptive impact to the society at large. Thank you very much for your kind attention.
Thank you, Professor Chakraborty. Allow me to now invite another esteemed panelist of ours, Professor Rohit Srivastava. His topic is Affordable Healthcare Technologies for India. Before I invite him, a brief bio of Professor Srivastava is right before you. He's, of course, been with IIT Bombay since long, 2005, and his area of specialization is point-of-care devices, biomedical microsystems, and cancer nanomedicine. He again is a very distinguished faculty, member of numerous academies internationally and nationally, receipt of various awards again nationally and internationally, and the recent being Vigyan Shri in the year 2024. And he is again handling number of PhD students, master students, postdocs, and other staff members. I now invite Professor Rohit Srivastava to kindly deliver his talk.
Thank you very much. And thank you, Professor Manna, for the kind invite. We are honored to be here talking on the National Engineers Day, because we as engineers are proud to have contributed in a small way to the medical community in this country, and we hope that we can make a much bigger impact. So thank you once again. Let me share my screen. An excellent talk by Professor Suman. We all learn so much when he delivers such a talk. So I come from IIT Bombay, and today I'm going to talk about affordable healthcare technologies for India. Our lab is situated in the Department of Biosciences, Bioengineering at IIT Bombay. And we, of course, have been in this space for about 20 years now and hope to keep contributing to the healthcare ecosystem of India for the next 20 years at least. So if you see this slide, this is the first slide I usually show talking about the interdisciplinary nature of our work. And this is important because coming from an engineering institute, how do we actually get into technologies which have an impact in the medical space? Now, most of us are working at such institutes, but we are not using such institutes to our advantage. Specifically, the one that I come from, IIT Bombay, we have these different engineering departments, and many of these: chemical engineering, electrical engineering, mechanical engineering, industrial design. And we also have many science departments, and these are all making a big impact in their spaces. But of course, in their own, what happens when you combine science and engineering and then you make them partner with some of these medical institutes which are near the campus? Because so far we don't have one on campus. There is a plan to set one up. But if we can actually now start collaborating with these medical institutes, get problems and statements of such problems that Dr. Sarin mentioned, and I'm really impressed with his thought and his vision for the future, because this is what India needs. Then we can combine private and public funding, and there are enough private people now wanting to put money in such projects, and then take them through the entire life cycle of an idea to a product. And Professor Suman mentioned that, how do you take an idea and then actually make a working product, which is then put into the clinics, which actually then continues to generate impact. Now, what comes out of this is either you have your own startup, or you transfer it to a medtech, or you do it in partnership with somebody. But in the end, what you're doing is that you're adding to the capacity in this country. You're creating these high value jobs, and you are creating these indigenous products. Now, one slide I do tell about, and this is the slide which typically should come towards the end also, but it comes in the beginning, because most of us are aware of the top side, which is the expenditure that India does on healthcare per person. And you see that number, India is sitting at the bottom there, somewhere at $75 per person per year, of which 30% is public spending, while 70% is private spending. Look at a country like Brazil, look at a country like Russia, and you see the difference in numbers. Now, which means that we have our own challenges and we have to have our own solutions. Now, the challenges are, and you can see those in the bottom two sort of blocks. On the left, you have the challenges, and the solutions are on the right. And this is something that I do keep talking about. How we can interface with clinicians to make such solutions accessible to everybody. And most importantly, you can see that we have to have devices that can now be monitored remotely, and you can give greater access to underserved communities. Dr. Sarin talked about digital twins. This is a technology that even our lab is working on. There are groups in IIT Bombay that are working on, and we hope that such technologies are able to reach the underserved communities, because people like Dr. Sarin, sitting in a tier 1 city, with so much of experience, can do wonders if there can be more such people sitting everywhere in the country, who have the experience and the knowledge that Dr. Sarin has. So this is a big gap. Of course, it will need to be tackled, but there are many, many challenges, as you can see in the bottom left. We have only 1 million registered doctors that are catering to about 1.5 billion people now. And we have very big lack of sophisticated pathology labs and trained technicians, which is what Professor Suman said, that we need more easier to use devices and more easily deployable devices. But there's an excellent opportunity. And this is what I keep telling my students. If we develop such technologies, we can cover not just India, but other emerging market economies. Now, we have many research areas. We work across the entire engineering domain, bioengineering domain. In the sense, I come with an electronics engineering degree, but I also have a degree in biomedical engineering, which means that I have learned medicine, physiology, courses, and I can also see how these can be interfaced. So we worked in not just point of care devices, we worked in maternal health, we worked in lateral flow assays, we worked in IoT based medical solutions, we worked in drug delivery, and there's a big impact in drug delivery space in India. And of course, we've gotten into new areas like pain management and ICU management and stuff like that, which I'll show you. Of course, the lab gets a lot of recognition, but most importantly, the ones at the bottom and on the top you see are the student-led companies which have come out of the lab. And this is what makes us proud, that what we do can actually be taken to market through these student entrepreneurs. And we have several of these coming out of the lab. The most notable amongst them is, of course, the Biosense Technologies Private Limited, which started out in 2010 from my lab, and the Neodocs, which started very recently, about 3 years back. But both these have created a big impact. There were several products that came out of our lab, went on into the market to create an impact. The one in the center was an MTech project from my lab, which went on to become a commercial product and actually gained a lot of recognition, because it was the use of mobile phone diagnostics in this country towards a product for the first time in 2011. And what we could do was we could take these urine dipsticks, the 10 parameter and the 10 plus 2 parameter, which is looking at creatinine and albumin. And then we could actually make such strips which could be used with a mobile phone diagnostic platform technology, and then readings given which are as good as a Siemens Clinitech machine. So the comparator always used to be the best in the market, and we had to get to the best at the lowest price. We also came out with our own glucometer, as you see on the right, which made a big impact again in 2013. 2013, it was launched in the country by ICMR, and it created a big impact because we priced these strips at 5 rupees in the Indian market. And of course, the one on the left is the technology that came out through these student interactions, and they made a big impact. Many more from the lab. I'm not going to talk about all of them, but I'll do talk about some of the startups that came out of our lab. We do have a big technology using micro needles that can now be used not just for a simple application like pain management, but they can also be used for vaccine delivery. And we have now started working with a group based out of UK, which is also working in vaccine delivery, and we are combining strengths there. We've also got our own version of the lipid analysis assay, and this was given to us by BIRAC as a funding through their AIR scheme. This was transferred to the CRS scheme by BIRAC, and then finally it is now a product which is being approved by the Indian CDSCO to be released in the market within a couple of months. The example was that we could use these paper-based strips to create a device which goes through several iterations. Now, as engineers, we tend to do that, but when you do that, you actually come out with an assay which can then be compared in the hospital settings and finally be able to take it forward. The important thing to understand here is that these two things you will need to scale up in a production facility, which we've now set up in Mumbai. And hopefully with these two production facilities, we should be able to start marketing these strips and reader through our own startup company. But as you can see, we now have a device which can give you total cholesterol, HDL, LDL, triglycerides at point of care. We've also made an assay for troponin, and this is being a big marker today for cardiac diseases. If we can make such assays which are as sensitive as the Roche assay, which is the one that is available in the market. Of course, the Roche one claims to go down to 1 nanogram per ml. It does not. We've actually tested the Roche with our own, and both of us cannot go down to 1 nanogram per ml. Hopefully, in the future, we should be able to get there. We've also developed our own bioresorbable bone screw materials for bone and soft tissue fixation applications. I'm showing you examples of different technologies in the lab, but important thing to understand is that if you take up one such application, you have many things that you can do as engineers and people who have interface between science, engineering, and medicine. Of course, we have our own screw materials, which we have made out of novel material, which is now patented by ICMR in not just India, but Europe and different countries, US, Japan, and many other countries, so that this can then be marketed to other countries as well. Important thing again is you have to set up manufacturing for it, make sure that you have capability to test it in humans, before you do that. But again, you have to have a supply chain for it. We have several, of course, USPs of this. We've just transferred, last year, we transferred a technology to Bios Healthcare, which is based out of Ludhiana, for an antimicrobial mask. And of course, there is nothing big about it, but if you can use nanoparticles to kill virus on contact, there are applications that these masks can have. We have smart dressing materials whereby we've combined now these the micro needles with drug delivery and created a smart patch, which can then be able to deliver a certain amount of drug, but then the micro needles can help the tissue get regenerated faster. Of course, smart wound dressing materials are now moving forward from our lab because they have been transferred to another company, which is taking it forward. We've also got several of these products that are in pain management that my own students' company is taking forward. I'm not going to go into detail, but a lot of things, once you start talking to clinicians and people like Dr. Sarin, you start getting a lot of ideas that are problems that are being faced by such clinicians. This again came from a maxillofacial surgeon where he wanted to make such drug delivery devices, technologies which could make sure that post maxillofacial surgery, no infection happens. We've done that as well and transferred it to a technology, to a company. Set up many startups in the last 2 years. EffectMed was our first startup about 2 years back. It is already valued at about $3.5 million with 1 million raise. And this looks at bone regeneration and repair. We've got 2 products in the company, the bone graft and the resorbable screw. As you can see, the first one is moving to market because we've already set up manufacturing. We've got a DCGI approval, and hopefully with this, we should be able to get the first one to market. It is being done in collaboration with AIIMS. The second one will move, subsequently. Of course, we did that with another engineer in our team, Professor Jayesh Bellare, who's a chemical engineering person, but of course working a lot in the bioengineering domain. And both of us having students in the company, we've been able to move this forward. We set up another company around point of care diagnostics, which is looking at the lipid assay as well as the glycated albumin, which is a third marker for diabetes assay. Hopefully, these 2 products, and this we are working in collaboration with AIIMS. We have Professor Nikhil Tandon as our clinical advisor, and hopefully, these 2 products, which have now been supported by many of these funding agencies, will move to market in the next 12 months. We've also, of course, been looking at not just diabetes and cardiac. We've also looked at kidney markers and made a device and assay around that, which can then be cloud connected. The MedInnotech set up by one of my students. In all these startups, I have my own stake in the startup, but most importantly, I want the student to lead these startups. So we've got our own pain management and infection management sponges. We are using our microneedles for pain management, the sponges for infection management. And we've got gels for, again, pain and infection management, which can be used for intra-articular delivery systems. We've set up another startup in women's health and women's and reproductive health, and this is looking at fertility issues in women and men. And this startup has products which is moving end to end. We've just sort of finalized the funding from Singapore. Hopefully, with this funding coming in, we should be able to move this product all the way to clinical studies, because the Singapore company wants to not only do it in India, but also do it in Singapore. We've got another startup in clinicosis, in digital health, and this is looking at several products. We started off with the innovative fluid alarm system, fluid alarm flow system, and this one will actually look at remote healthcare monitoring devices. We have the first challenge of monitoring IV fluids, and we made a simple solution. Of course, with engineers in the team, we could make a simple solution that now can be deployed across the hospitals in India at a very, very low cost, costs of less than 10 rupees per bed in the hospital, which makes it easier for most hospitals to take up this technology. We are going with the defense services, a hospital with this product, and hopefully, once we have traction, then we can move it into the civilian market. We've set up another startup. The name of the startup has changed because we did not get this one, but we've wanted to move all our lateral flow assays into a product, and we've made such products now where we have the assays created, and then we have a device around the assay which can look at not just troponin I and T, but also HbA1c and thyroid markers and many other, vitamin D. And these are all the products that will be there in this one startup. Of course, we've tech transferred many technologies, as I showed you to Yashraj. We've also transferred a very nice technology to Morpheus Private Limited, which is looking at feeding port enabled non-invasive ventilation mask. None of the ventilation masks in the country have a feeding port. We actually innovated and built one in it, and it got transferred to this company, which is now manufacturing this and selling in India. So this is becoming a big market, because every year there is a market of more than 100 crores in such non-invasive ventilation masks in the country. Of course, a student's company is making a lot of impact in women's health. And how do we monitor women's health? Look at the chart of India there, and look at the number of tests that have been performed by this company. I am also an advisor to this startup, a PhD graduate from my lab, set up this company about 5 years back. Today, they have reached 1.5 million women, and they have been able to do more than a 250,000 tests, thereby providing these people with the best quality healthcare, as Professor Suman also showed in his presentation. Neodocs takes it one step further, where we had a mobile phone based diagnostic in a platform technology. Now these people, as Professor Suman also showed, without having a device, can you now use your mobile phone, take images, and the data then gets generated and then gets transmitted to both the clinician as well as the patient. This company has raised a lot of money. They're already valued at about 100 crores now in this country. Maybe in the next raise, they'll be valued at 500 to 1,000 crores. But the valuation will depend on how much revenue they generate. And this is what we always push these companies for, in the sense that they have to keep working on innovative technologies that reach the market. We run a biodesign program at IIT Bombay, and this is a unique program, as Dr. Sarin mentioned in his last slide. How do we involve clinicians in engineering institutes? How do we involve the sort of engineers in medical institutes? This is one way of doing that. And just for the advantage of people listening in, please feel free to apply to such a course if you are interested in working on medical technologies. Being an engineer, how do you contribute to medical technologies? Being a medicine person, how do you contribute to such healthcare technologies? Having an engineering component. We've got both of these. In the first round, we have about 6 of these clinicians in our team and 4 non-clinicians. But what is important is that these clinicians are working in teams with non-clinicians to create such medical technologies which come out as needs from the hospitals that we already have tie-up with. We have Dr. Manish Agarwal, a very renowned orthopedic surgeon, associated with this program as the co-principal investigator, and he comes from Max Nanavati Hospital. And then we have a lot of these internships happening at the hospital site as well. But our goal is, over a 12-month period, we will train 10 such fellows, 50 such fellows over a period of 5 years, and keep doing it over the next decade or so, if we can show impact. But good thing is that there will be technologies coming out of it. There'll be student companies coming out of it. Of course, we've done a lot of work over the past 20 years, but most importantly, I want you to focus on the leftmost corner. We've been able to file 250 plus patents and get more than 85 of these granted till date, which is creating an impact, because most of the products that go out to these student companies have a patent that they can rely on. And of course, many people impacted. If you can keep impacting the healthcare ecosystem in this country, then you should be continuously doing such work, because India needs more and more such engineers to create such impact. Of course, we do a lot of outreach. We get recognized by the government, and we have a very large partner network, not just hospitals, other engineering institutes, many medical colleges, and of course the Indian Navy being a very big partner of us, because we now have our own student graduate who's working at AFMS Pune as an assistant professor, who is now liaising a lot of work between defense and our institute. We have a large lab, and Dr. Renu Swarup came and inaugurated the Medic Biodesign program at IIT Bombay. This is now hugely successful in the first year itself, and hopefully, with the impact that we continue creating, we'll train more clinicians to work on with engineering teams and create impactful medical devices. My heartfelt gratitude to my 3 mentors, and I keep telling about these people to everybody. If you have mentors, please do not forget them. They are always there behind you. They'll always keep blessing you. They'll always keep supporting you. And this is what Professor Padmanabhan, Dr. Manju Sharma, and Dr. Renu Swarup have done for us. for my lab, for people like me across the country. Thank you very much.
Thank you, Professor Srivastava. Extremely grateful to you. Both the esteemed speakers are available with us for a short while, Professor Chakraborty and Professor Srivastava. I request the esteemed audience, yeah, I can see a hand, Dr. Prabhat Mitra. May I request you to kindly throw open your question to the esteemed speakers, please?
I have one question to both Professor Chakraborty and Dr. Rohit, saying that, what is your level of interaction with government medical colleges and hospitals, other than AIIMS and Air Force and other things? What is the level of interaction?
So I'll go first, sir. Thank you very much. Of course, medical colleges and institute. We in Bombay there are two such medical institutes and colleges: the KEM Hospital and the Sarin Hospital, and we have interaction with both the hospitals in terms of doing joint research as well as doing validation of our products at the hospital. And this is only possible because some of their clinicians are interested in research. Most people have very little time because they are already seeing 200 to 50 patients a day, which is why we cannot trouble them so much to do many of this stuff. Thank you.
Okay, now Professor Suman, digital health outreach, Professor Suman, right? How well is it implemented in Bengal in terms of having the decentralized approach to doing things?
Yeah. I mean, this is something where I have primarily focused on this unorganized sector. That means it is not a hospital, it is a, you may say, a last mile healthcare delivery center. It could be a primary health center or digital health center. Sometimes we call in a very colloquial language as health kiosk. So this is something which is very much not a part of the structured system. But for the structured system, we also have a solution that when we see a doctor interfacing with a patient, the major challenge is that huge numbers of patients who are coming for medical attention, everybody will not require the same level of intervention. So if we can have a multiple layer of screening, and first few layers are done only by technology with maybe a frontline person handling it, not technology only giving a outcome, but maybe a junior person, maybe a junior doctor, or maybe even a certified health worker, not any arbitrary person, who can take care of that first few layers of screening. So I have already tried to implement that for cardiovascular scenario, because cardiovascular is a problem where we have a huge discrepancy between the number of experts and the number of patients. We have very few high level experts and huge numbers of patients, and including emergency patients. So when the patients come, and there are some patients whom we very loosely call as fancy patients. That means they are not really patients, but their company is sponsoring some health checkup and all, and they are very happy to do the checkup when actually that may not be necessary for them. It's a wastage of time and resource, whereas for others it may be very critical. So how can we have a multi-layered screening of these people so that only those who need the main high-end intervention gets into the use of resources? So this is perhaps something which is very much needed for our hospital system to manage the crowd. And bottom line, the hypothesis is that the crowd is large, but everybody is not requiring the same level of intervention.
Correct.
So we can decentralize that, and I think the use of technology at different layers should be able to simplify that. But this is something that as technology developers alone, we cannot have our last word. So that is why you will see that we mostly have our interventions or pilot programs at locations where we have more control. That means somewhere a not-for-profit organization is running a healthcare system, which is a government supported program, but not directly a hospital. Because directly interfering with a hospital's day-to-day program will have huge other implications, starting from social to political and all. And it is not so easy for us as technology developers to directly get into that unless there is a clear policy which is recommending that. That is the major issue. The technologies are there, but there has to be a clear policy which will make the thing functional. I think Rohit will also agree to this.
Is there any more question?
Working as principal scientist at CSIR Siri as well as INAE Young Associate 2021. Sir, first of all, congratulations to both of you for carrying out wonderful work and inspiration for many of us. Sir, I have started my work in the domain of early stage cancer detection using terahertz based systems. So I would like to have your opinion in this regard, like especially in vivo based imaging system. So, if possible, if you can provide your opinion in this field, early stage cancer detection using terahertz based systems, sir.
I can make a brief remark on any of the cancer detection schemes. First of all, early stage is the most important aspect, because early stage is it is giving an opportunity of you can say a very effective treatment for the disease. Now the challenge is that we although call it a detection per se, but for the cancer, the gold standard remains to be the biopsy. I mean, at least for the solid tumors. So in that case, the challenge is how we calibrate the efficacy of what we are screening with the gold standard, the biopsy test results, given that we are trying to use all these technologies because we want to avoid biopsy at the first place and come up with a recommendation which will not require such intervention and resource. So, the terahertz technology that you are talking about is very, very important and crucial, but I would recommend that whatever technology you are developing, as an engineer, we have always learned this from our own mistakes, at least in my early development of these things, that we try to emphasize too much on technology and not really emphasize that much on calibrating it with respect to a acceptable medical standard.
Yes.
So please try to have equal emphasis, if not more, on calibrating what you are developing as your what I would call as maybe detection or screening technology with something which is benchmarked as a clinical or medical reference standard. So please try to see in whatever screening or detection you are doing, what are the acceptable standards, and try to develop cohort studies which will lead to that.
Thank
If
you.
you are able to do that, I think that's wonderful, because these technologies are more and more needed for our nation.
Thank you, sir. Thank you so much.
Thank you. Any comments, Professor Pandit, sir?
Only thing is a compliments to all the three speakers on an excellent theme which has been chosen, because the issue of engineering solutions which are utilitarian in nature should involve some social angle, because it will remain otherwise a technology developed by engineers for their own satisfaction, and bringing in line with the requirements of medical is one way forward. Similarly, other engineering practices will also need to look at the societal acceptability of their innovation, as a result of which, as correctly pointed out by Professor Suman Chakraborty, that we need to have some social acceptability standard for the innovation, for a general development and improvement in the society. So my compliments, we have made a big start, at least in addressing the issue and trying to bridge the gap between medical science and engineering sciences and technologies. And I'm sure this will result into a revolutionary ideas coming from our country. And I'm sure this will help both the professions to grow simultaneously. Again, thank you very much to all the three speakers of today, and I'm grateful for their acceptance and making this Engineers Day a memorable one. Thank you.
Thank you very much, sir, for your appreciation, and we look forward to accomplished seniors like you, and we need your guidance and blessings for the way forward.
Thank you, sir. Allow me to thank the esteemed speakers and all the esteemed fellows and participants here today for this wonderful session. It's a beginning, as Professor Pandit said, and Professor Manna has asked me to thank personally as he had to move out. And this would be taken forward in a suitable manner at a correct platform so that the ideas given do not get snubbed away. Thank you very much, and Jai Hind.